Hi, it's Paul from Heritage. So we're looking at a slightly different Heatmiser system today. So this is quite a dated electric underfloor heating system that is still functioning fine, but they wanted to update it to some new controls so it's app controllable and a bit more efficient, and then also add the immersion heater onto it for a few different reasons. So yeah, we'll show you around and show you what we've got. Okay, so we've got these old thermostats here which still function. So that thermostat is controlling some electric underfloor heating that covers this entire area, I'm assuming, this L-shaped lounge. Down here we've got this thermostat and I'm assuming 2 heat mats. Then upstairs we've got same again, thermostat, 2 heat mats, and then we've got an immersion heater as well. I'll show you them in a minute. In here we've got 2 phases coming into the building because the power demand was so high, it's required that additional phase. So yeah, there's your normal consumer unit that just supplies the main house. And then this board is specifically for electric underfloor heating mats, and then we've got old pottery as well. So I think this board's on an off peak. Yeah. So I think this board's on economy 7. So that means the power will be off to this currently and only comes on between midnight and 7. So that's what has been installed in here now for, I'm not sure how long. I'll find out off the customer. This is quite an old system, this, and it's been running for a long time and it's still functioning. So outside there is a building that used to be a pottery barn, and you can see there that's got a 45 amp breaker going to that. So you've got almost a 50 amp supply over there because there'll have been a kiln or something like that for the pottery barn. So you've got 45 amps of continuous load there when that was on. And then also underfloor heat, so you've got 2 contactors here as well. So again, I've not checked yet, but I'm going to obviously confirm all this, but I'm assuming that the thermostat switches the contactor and then powers up the elements. So if you were to put a standard Neo E thermostat onto, say, a heat mat that was this size, it would blow the thermostat, you know, to pieces internally on the circuit board, because that's a maximum of 16 amps it could switch. So maximum it could switch one of these heat mats alone. But because the rooms are so big, you've got, you know, multiple heat mats per room. So yeah, so I'm assuming the thermostat switches the contactor, which then in turn switches these heavier load mats. So we're going to need to reuse these contactors if they actually do that job, and put the Neo E's to switch the coils in these, and then we're going to check the loads and see what all this is using. So yeah, that's what we've got here. So there's the immersion heater. This is connected to a solar thermal system and is what heats this tank. This is, again, has been installed for quite a long time and is still all functioning fine. But I think this is all coming out and it's going to be changed, so it's having a new roof on it, new solar panels and battery storage. So this system's all going to be coming out. So what they're going to have to do is start using the immersion heater in here. We need to add this immersion heater onto the Heatmiser system as well, and then we need to add a hub in the property so everything is remotely accessible and controllable. So all we're going to be doing on this system is adding 3 controllers, hub system, and then program it all so it's all remotely controllable. We've got the main meter here, which is off one of the phases, which supplies this consumer unit, main house, and all this is being completely rewired anyway. So the entire house is having new roof, new solar panels, new heating system, air source heat pump. All this stuff's coming out at some point anyway. So in the meantime, what we're doing is trying to get the heating controlled properly and the hot water controlled, so they can use it whilst they're living here while some of the work's going on. And then when the big work's going on, when it's basically they're not going to be able to live here because there's going to be so much work going on in the house, they're going to have to move out. Then what we're going to need to do is salvage this electric underfloor heating, because they want to keep this floor in here. So we need to salvage the electric underfloor heating down here, and upstairs is going to be having a new wet system installed off the heat pump. Plus there'll be radiators, you know, and then that'll also supply the water tank as well. So there's going to be a lot of changes. So this economy 7 meter won't be required anymore. We're only going to have one electric underfloor heating down here, which is contribute to the maximum demand of the house. And then the rest of the heating and hot water is going to be done off the heat pump, which might be about 20-25 amps or something. For now, we need to get this functioning and controllable until it's ready to be ripped out. And then the Heatmiser system that we've installed here is going to be expanded on throughout the property then. So we'll be able to control radiators, we'll be able to control the heat pump, the underfloor heating off that, etc. So it's going in now, but then it's going to have to be adapted and altered later to suit the new system. There's a lot of singles coming in here, so there's like no grommet strip on there, so that can damage cables that enter the board. And a lot of this it looks like singles, maybe it's double insulated. But yeah, these tails coming in here basically are the ones that go to the heat mat. So that one there is quite a flexible cable. So they go to the heat mats, they go to the heat mats directly. So I don't know where the connections are for them, but they just kind of disappear. Some of them disappear up there, and I can't see any joint boxes anywhere where it attaches onto. Some of them it looks like it goes down into here. So we might have some. I'm going to open that and check what's going on in that. But basically what's happening in here then is you've got your economy 7 supply in to there. And then we've got supply to the kiln, which is not needed anymore. They're also wondering, yeah, if they're able to switch the system to single phase. But if there's too much demand, then we might potentially have to keep the second phase. But yeah, got to check all that. So coming in here then, you've got this 45 amp breaker. It's got that cable goes out there. That goes into the bottom of this contactor, which is in 6. And then it's connected out of 5, which then supplies the bottom of these 2 breakers here. So that one contactor is supplied from, the supply comes from a 45 amp breaker through the contactor and supplies both of these where you normally would have your buzz bar going in. And then these 2 breakers then protect the cables on the outgoing side. So that one's rated at 16 amps. They do look quite big these cables, and this one's got 2 stuffed into it. So there's 3 heat mats in one of the areas by the looks of it. That's why that's a 32 amp breaker, because you've got 2 circuits stuffed into the top of that, and this one's only got 1. So yeah, this contactor supplies them. This contactor is supplied, so there you go. So there's another 32 amp breaker there. It comes out of there, goes into the contactor at the top, out of the contactor at the bottom. It supplies these 2 MCBs here, which has just got a circuit in each, and it's 2 16 amp breakers. So I'm assuming these circuits are rated at no more than 16 amps. And then you can see you've got a connection coming in here into the A1. I'm assuming this is the supply coming from the thermostats, which will then activate the coil, switch the coil, pull the magnet in, and then allow power through to these MCBs. If there was ever an issue with overload or short circuit, it would trip them out. So took this cover off, and yeah, this looks like it's a galvanized conduit coming up with the single core cables in from the heat mat, I'm assuming from this room. So we've got two coming up here which are then jointed in these connector blocks and go up. there into this board here, and when I move them, it's these two that go to this contactor here. So the A1 from this contactor goes down to here. First issues we've found are there's a 3-core cable being used, and you can see that the earth strands on the cable have been used as a live conductor, and then they've pinched an earth cable from, you know, a light switch or something on the back of this wall. So that's bringing the earth to this, to earth the plate, so at least it's earthed, but they've used a non-insulated earth conductor as a live conductor with a bit of like red insulation on it here. So I can't reuse that. So my idea was going to be replacing these with the Neo V2s, because the load is being taken care of by the contactors, not the thermostat. So I would have technically been able to put these in place of these. So this is completely doing air temperature. There's no floor probes going anywhere to monitor floor temperature. So what the customer just said then is ideally I'd like to be able to control both air and floor. So eventually when this place is rewired, we might just take a few pieces of this floor up, run a floor probe in, and then glue them back down again. So at least it gives us a floor probe down here to be able to control air and floor temperature. So because of that cable, and I being the way it is, and I can't reuse that because it isn't safe to do so, what we're going to do instead is, in the meantime, is mount a wireless receiver in here. We're going to add 2 Neo Air V3s to the system, and then just leave them on just stands on desks, on counters or whatever, and get rid of the 2 thermostats that we've got in here, because that way I don't have to use that cable between there and there, which isn't safe to do. And then that way we can switch the heating on and off with the receiver instead of the old school cable and thermostat. Right, so this is the peak consumer unit, and as you can see there, you've got a red cable connected into the bottom of the 100 amp connection where the buzz bar is, going to this isolator, and then this isolator then is the isolator for the Annex. The Annex doesn't have any overload or fault protection the way this has been done. What they've done is the power supply comes in from the tails here, it goes out through the RCD, and then on the outgoing side of the RCD you've got the buzz bar. But there's a reason why you have these MCBs after the RCDs. So this is only providing protection for earth leakage, whereas the MCBs give you your overload or fault protection. So it goes straight out the RCD into a main switch, and then the armoured cable there is that's what goes out to the Annex, and that's connected directly onto a 100 amp supply. So this cable here, it looks about like a 16 mil, and that is not capable of carrying 100 amps. That needs protecting with a fuse. We need to put this into a switched fuse to protect the cable from overload or fault current. The little cartridge fuse will do that, and then there'll be a main switch to isolate it, and then any other protection is on the final circuits over the consumer unit in the Annex. So the way this has been done isn't safe or correct. I've just turned 2 rings on the electric hob on and the oven. So this is what the current is being pulled through the main house at the minute. And then on this board, so one of the underfloor heating circuits, so I think that's underfloor heating music room, is pulling 26 amps. And then underfloor heating lounge is 21 amps. So that is 71 amps. So that's high current using equipment, and the stuff is, when it's on, it's continuous. So all we've got on the property at the minute is 2 rings on the hob, one of the ovens, and 2 electric underfloor heating circuits, and that's at 71 amps, and that's no additional equipment that's not yet been added to the installation. So yeah, that kind of, like, this alone is pulling quite a lot of current, hence why it's been put on its own phase. Okay, so we're day 2 now. Yesterday ended up doing more of load testing on the property because there's going to be some massive changes here. There's going to be some big current using equipment installed. So there's going to be a car charger, there's going to be an air source heat pump, and currently this installation's on 2 phases because it's 100% electric, and it already uses a lot of power right now, but that's because it's got 2 electric underfloor heating circuits. One of them is going to be going, but we are keeping one. So we did a load of testing yesterday. I was also removing heating wiring and then also testing the underfloor heating circuits, checking the loads and things like that. So we was doing more of that yesterday, and then finding out how we were going to control the heating, because my original plan was to install some Neostat E's on the system and then have them switching the relays. But the way it was done, it wasn't safe. I've had to change it now. We're going to use some Neo Airs to control the system, and basically the wireless receiver switch the contactors instead for now. Then when they do the full rewire and all the other work is done, then we're going to install some wired thermostats and then add some floor temperature probes into the situation as well. I think we measured yesterday that with the 2 underfloor heating circuits on the music room and the lounge, and then just 2 rings on the cooker and the oven, was 71 amps. And we've got 2 electric showers in here, we've got electric water heaters in here, we've got an Annex over the road, so this can be pushed way beyond the 100 amps, so hence why it was split. So even though we're going to be losing some of this, like one of these underfloor heating circuits, which was 28 amps, so we're going to be losing 28 amps, and probably one of the electric showers, we're probably going to be losing 58 amps there. It is high power equipment, and it's a continuous draw when it's on for, you know, a decent amount of time. If we're going to be losing 58 amps of appliances, but we're then also going to be adding a car charger, which is 40, and then we're going to be adding a heat pump, which is 25. So basically what we're losing, we're putting back with different appliances. It's still a very high load house basically, and even with the solar taken into consideration, there's 20 kilowatts of battery storage when it isn't producing as much energy in the winter. Then batteries are also going to need charging at certain periods of the day. It's a very high power demanding property, or multiple properties if you want to call the Annex a separate property, which it is really. So we've established there is 3 phases coming into the building. What we're going to do is this system is going to be upgraded to a 3-phase system, because currently it's running on 2. The reason why we're going to do that is because he had originally planned a solar installation with a single phase 9 kilowatt inverter. So what needs to be done is it needs to be a 3-phase, because apparently we can't use the inverter on 2 phases. So he said it's either a single phase or a 3-phase inverter. So we're like, right, so if we upgrade this to a 3-phase board, we can distribute everything a lot better. So it'll just be all on one board then, on a 3-phase board. So what we're going to have to do is make this cupboard area larger. We're going to get the energy company to come and switch this over to a 3-phase meter. Then we're going to take all this out and we're going to reinstall it in a 3-phase panel. Then the car charger can go into that. The 3-phase solar inverter can then go into that, because there's not really any room in here for, you know, upgrades and additions. Then, you know, obviously the new heat pump and whatever else, the full rewire. And then the Annex over there is on this armoured cable. So that can go in, I think it's I don't know if it's a 4-core or a 5-core. So basically we can, to spread the loads evenly, we're going to need to upgrade the panel in the Annex as well to a 3-phase. So all the load is as evenly balanced across phases as possible. the Annex on the building. So you've got electric shower. So yeah, in here we've got central heating, so it looks like there's 2 storage heaters in here, lights, water heater, sockets, and then electric shower. And it's on a 100 milliampere CD as well. I don't know why. This is wrong anyway, it's been done wrong. It shouldn't be a 100 milliampere CD. So the house has got one in. I assumed they'd put a 30 in here and 100 in the house just so there was some discrimination, but they've used 100 milliamp in here as well. It's not a rod system or anything. A TT system. That's in here. So this needs to be upgraded also. Just doing another little load test on this side of the installation. So I was doing a bit of a combination of 2 yesterday, so this is the side that we need to, that's the current house, the current annex, and then that we also need to add a heat pump to and add a car charger to. So at the minute I've got 2 rings on the hob, on the cooker, the oven, electric shower in this property, and then I've got the just an instantaneous water heater on, which heats the sinks up in the annex. So an absolute fraction of the large current using equipment. There's a meter going for it. So there you go, we're at 63 amps. That was quite effortless to get that to 63 amps. That's not taking into account any of the sockets in this building or the annex. No kitchen appliances, apart from what I've mentioned. One of the electric showers being off, none of the lighting being on in here or in the annex, none of the storage heaters being on in the annex, and also none of the new equipment being added to it. So back to the Heatmiser. So this is the equipment that we're going to be installing. We've got 2 booster plugs, 1 hob, a Neostat V3 for the immersion heater. And then we've got 2 Neo Air V3s, which are going to be doing underfloor heating in here, underfloor heating up in the music room. So I'm just going to pair these now to what I've installed over here. So what we've done over here is, so I've disconnected all the wiring out of this that was controlling the relays, which was the old thermostats basically. So we've got rid of them connections out of there. We've disconnected the cables in here that go through to the thermostat in the other room. So we've just used a RF switch V2, which has got 2 heating channels on it, and it's got 1 hot water channel on it. So 3 separate channels on this unit. So we've got a power supply from the peak consumer unit. So we've got a live, neutral and earth. I've just nicked it off the lighting circuit for now, just to power this. I haven't took the supply from this consumer unit because this consumer unit is off currently and only comes on in the off-peak hours. So this is only being used in the off-peak hours, but every time the power went down to this, it would disconnect from these thermostats, and then every time the power comes back onto it, these would be trying to reconnect to this receiver. So that's the reason why I haven't used the power from this fuse board, is because I don't want that keep powering down on and off every day, because it's probably going to lose its pairing eventually to these, and one point it'll come back on and won't reconnect, and then the thermostats won't work. So I've put permanent power to this, from the peak board. And then all we've done out of this then, out of the switch sides of channel 1 and 2, we've come out of there, and then I'm using channel 1 and 2 to switch these relays instead of the old thermostats. So the A1 connections are the switched inputs for the coils, which comes from this 2-channel receiver. But then the A2 connections is a neutral connection, and that was originally tapped onto the neutral in this board as it should be. As we have an RCD in this consumer unit, the neutral would need to come from this connection here that goes through the RCD, because if we used a live from here but we used a neutral from a different area, it would just trip the RCD straight away. So we've had to take a neutral from this board, from this neutral bar, and the live from this buzz bar, which is also going through this RCD, and I've powered the A2 connections from this neutral to prevent this RCD from tripping. So that's why we've done what we've done in here. I can just do a quick dry run. So if I push this now, it will switch the circuit manually without any thermostats connected to it, and it should switch our relay, one of our relays, on. There you go. So it looks like that's channel 1 is music room. Turn it off again. Channel 2. There you go. So you can see the little red symbol on that. The little red window on there, flicking it out. So channel 2. Is switching our lounge. Channel 1, music room. Channel 2, lounge. So that's me manually doing it. So all we're going to do now is connect these to the correct channel on there, label this up and allocate it to the correct room, and then this will be doing the switching then. So as I mentioned before, this is an off-peak board, so there's no power coming into this, so our relays will be switching. So regardless of this board being off, the power to the RF switch is permanently on, and these are battery powered, so they are permanently on. So if we turn this up and it switches the contactor on, that will still work with regardless of power, but there is no power going through the contactor until the off-peak meter is on. So these will switch 24/7 if they need to, and these contactors will be switching on and off according to the temperature in the room. But that doesn't necessarily mean that the heating is on. The heating will only work in the off-peak hours. There's a receiver now, labelled up. Channel 1 music room, channel 2 lounge, so we know which one's which. Got a right load of drama with this. Wireless connectivity problems. Right, okay, so there's the hub. Plug straight into the router, and then there's a power point under here that we've got it plugged into. That's kicking out the RF network from here. So that's like the main controller. Then what we have done, as this place is quite old and there's hardly any plug sockets around, so there's lots of extension leads everywhere, so there's nowhere to actually plug these boosters in the right locations. So let's see, so we've put one underneath the stairs here, plugged into that. So we've been having a problem getting through this wall because it's quite a big thick stone wall. So I thought a house this size, 2 boosters, plus this is going upstairs, which that is a mesh node as well because it's a Neo E. So the Neo V2s and the Neo E V2 act as a mesh node, so that'll boost our signal upstairs and act as a booster anyway. So I've got to put that in next. So yeah, so we've got our hub over there, and then in the same room on the opposite side of the room we've got a booster plug there, which we've connected, and then we've got the thermostat for the lounge here, which is now connected. As you can see, it's got the symbol on the top. The Neo Air V3s, or any of the Neo Air range, aren't a mesh node, so these don't extend your wireless network. So you need to have a good solid wireless network in here to be using these, otherwise they just won't connect, they'll keep dropping out. So that one's connected to the electric underfloor heating in here now and controls the contactor, as you've seen. And then we're struggling in here to get a plug to work. So it had to come pretty much to the opposite end of the building. But because you've got this thick wall here as well, it just would not connect. So I had it plugged in here and it just wouldn't connect. And then here's the thermostat, which is going to be controlling the underfloor heating in this room. There's the old thermostat on the wall just down there. So that used to control the underfloor heating in here, but we've disconnected all them cables now. So what I've had to do was plug an extension lead through here and the mirror to there. So it's literally in this door opening to where we've got a decent RF network in there, and then we've managed to get that working for now. So that's picking up on there, and then it's bouncing the signal through here, and then we've been able to connect this stat now. As you can see, it's connected. So that will do the controlled underflow heating in here. I've labelled everything up. Music room, and the other one on the back says lounge on it, so just in case these ever get taken off the stands and mixed up, at least you know what room it's come from then, because otherwise it will be controlling the temperature in the wrong room otherwise if you don't label them up. So this is what we've got now. We've got booster, hall and lounge, and then we've got underfloor heating lounge, music room, underfloor heating, which is in here. So I should be able to turn this thermostat on now via the app. So let's turn the music room up. Beyond the temperature, the room temperature's reading 21 there. So we've turned it up to 26. There you go. And I just heard the contact, because them contactors are so loud. They're like, I do like 50 amp, 60 amp contactors. You've got the little flame indicator there, which is showing that it's calling for heat. Flame indicator there. That's going to now try and get the room to 26 degrees, what we've got it set at. So yeah, this has then in turn switched that contactor in the board, which is then in economy 7 mode anyway. So at night, it will then allow current to flow through the contactor and then heat the electric underfloor heating up in this room. So let's turn it back off again. Wait for the little flame symbol to go off. There you go. Flame symbol's off, and then we'll have stopped the heating. Even though we've got a booster plug over there, I would probably recommend putting another one in here just to extend that mesh network a bit more. Even though it's functioning now, it probably could function a bit snappier. So, booster hall, which is this. I'll just show you the relay firing in. So we've got Channel 1 is music room. Channel 2 is lounge. So lounge is that one, channel 2. So there's no red in it at the minute. So we want to switch lounge on. Lounge underfloor heating. Turn it up. We want channel 2 to come on, and in turn we'll fire the relay in, the contactor in. There we go, channel 2. Yep, so we've activated lounge, underfloor heating. We just brought on channel 2, which is channel 2, lounge. And then it's brought this contactor on where you got the little red in the window now. So I'll turn it off. Okay, so we're gonna want this. Oh, there you go, it's gone off. Little red has gone now. Yeah, you could hear the click, couldn't you? There you go. So we're in here now doing the immersion heater. So what's in here is the solar thermal pumps and controls and all that are supplied from the immersion heater circuit. So this isolator here isolates all that, yeah. But then that just comes into the back of here with the immersion heater circuit. So I've just took the old 20 amp switch and replaced it. And then so what we've done is you've got the 2.5mm coming in, which is a 16 amp circuit. You've got a 2.5mm flex that comes in there, which is tapped onto that, which is supplying the solar thermal. So they're just all Wago together in the back of this deep box. And then you've got some tails coming off it that go to the isolator to supply the isolator. And then we've come out of the flex outlet plate on the front, which this will then go into the immersion controller that we're going to put on, and then the flex from the immersion heater will then go into the immersion controller as well. So that means regardless of this being in the on or off position, the solar thermal has got its permanent supply. Then this will be in the permanently on position when we're done, because we're going to be using control via this, but it's there as a local isolator if it's needed. So what I was doing, I was just doing my checks on this, and the tank stat is faulty. So we can't really run this immersion heater safely without the tank stat being right. There you go. Right. So normally what you would get is when you turn this, you'd hear a clicking on and off, usually. So the solar thermal isn't going to get this tank up to 80 degrees. Definitely not. Yeah, so if I turn this beyond 60, it should click on, and then it should call for heat from the electric immersion heater, if you like. It'll allow current to flow through that stat, which then goes from the stat, power in, through the stat, back out the stat, onto the immersion heater element. So this here is a switch. Once it reaches temperature, the tank, it then doesn't allow current through here and stops the immersion heater heating, because if it was allowed to get to 80 degrees, like this would do, if we switch the immersion heater on now and just let it, because this at the minute has got continuity constantly, so it would be getting the water to like 80 degrees, and then what it would do, it would be, the pressure would build up in this tank and it would be venting out, because there's a vent in the loft that goes into a water tank in the loft. So it would be blowing pressure out of this pipe that comes out of the top of the cylinder and then venting that pressure out in the loft, which, you know, again, you don't want these cylinders building up pressure, because they can be dangerous. So there's the, so I've got my continuity setting on now on my tester, and when I turn this, when I turn it down, the continuity should break and turn the switch off. If I turn it up to 80, it should again switch on, but it's in any position, it's just on. So that's faulty, and that needs replacing before the immersion heater can be connected. Right, so that's the general gist of it. Power in, power out the isolator to the controller, and then power out of the controller to the immersion heater. So I can't power this up yet because we haven't got the, I'm going to go and see if I can get a tank stat now, an immersion stat, and then I can get back and get this back on. There we go. New thermostat is installed. I've just done some tests. I've turned the controller on and made sure we had voltage to here, which we do. And then I've made sure that the voltage was going through the switch to the element, which it is. And then I've also turned the thermostat, the tank stat down, and then made sure that that has actually isolated the power to the immersion, which it does. So this switch now is going to stay permanently in the on position because this is what's doing the control now. So we've had to have put this Neostat E into time clock mode. So this can either be a thermostat or a time clock. So we've had to put it into time clock mode. Now I'm going to add it to the Neo app, and then we'll be able to program some on-off periods for the immersion heater then. And then what happens is this will be on for a period of time. As soon as the tank stat is satisfied, it will isolate the power to the immersion heater. So just because this might say on, so you might be in your on period of the day, but once the tank's satisfied, it cuts the power to the immersion heater. So it's not necessarily using energy just because the controller says on. So we're going to add thermostat. Immersion heater. So hopefully this picks up here because we had problems with signal downstairs, didn't we? So we're going to do push and hold tick. Push tick once on setup. Push tick again. Now it's searching for the network. There you go, bosh. Solid light. So it's found and connected to the network. So now we should be able to, there you go, device fan. We should be able to control it from here now. Finish. So we've got immersion heater is on at the minute. I can just hear that making a bit of a whistling noise now because it's well, it's starting to heat up like a kettle element does. So you have a little whistling noise in there. So let's see. So that is, timer is on. Timer off. On. Off. Cool. Okay, so we've just set up some basic times and programs on here, but it's up to the customer to kind of tweak it and edit to what they want. So this is what we've got now. We've got the booster hall, booster lounge, which are just both off because we're not using them, but they're still functioning as a booster because they're plugged into the power. So I've set two profiles up. We've got electric underfloor heating and immersion heater. Electric underfloor heating I've set Monday to Sunday to come on at basically midnight and then go off at 6 in the morning. That's because we're on the economy 7 here, and the economy 7 doesn't come on till midnight. So the only time you can use the heating here, because it's electric and it's on economy 7, is between midnight and 7 in the morning. So I've put it to climb up to 23 degrees at midnight, and it'll take its time to do that through the night, and then then set it to go back down to 18 degrees at 6 o'clock in the morning. So this is going to be doing its heating through the night. So that's the profile we've set up for that. Immersion heater profile, I've just set it on at 5 off at 8, on at 12 off at 2, on at 5 off at 8. You know, they can obviously be tweaked accordingly, but that's what we have done for 2 profiles. Then on the home, if you click on it, you can see it's used stored profile, electric underfloor heating. Immersion heater is current profile, immersion heater that I've set up. Stored profile, current profile, electric underfloor heating. So I've just done one profile for electric underfloor heating, which we can just use across both thermostats, and then we've done one profile for immersion heater, which is just specifically for the water heating. Even though I've set some immersion heater programs, I've currently left it on standby. So if we want to put that into to start using the profiles I've set up, you need to go onto immersion heater, and then you need to click on auto, and then it'll automatic means it just goes with the schedules that we've put in at the bottom there. And you can also manually override it to boost it. Say if you've got guests staying and multiple people have had showers and used the hot water out the tank, and your periods aren't due on to heat the tank again, you can click on override, and then you can boost it for through 2 or 3 hours, whatever you want to do. Push done, and then it will bounce to override in the middle, and that will start heating the immersion heater there and then. So that's what you need to do to boost it. So it's auto, override, or I'm going to leave it in standby at the minute because we're not using it because it's still on the solar thermal currently. So its immersion's left in standby.